All right, greetings everyone. Welcome to the third part of the video for section 2.2. Just finishing up our study of some properties of lines and related to their graphs. Okay, so let's now talk about finding the intersection point of two lines. So here we're given linear functions f of x equals 3x plus 1 and g of x equals negative 1/2 x plus 4. Find the point at which the two lines intersect. And first of all, notice in our picture here, we got this red and the blue line, which correspond to f of x and g of x. And we should first of all identify which is which. So the blue line there, which of those two is that going to be? Well, it looks like it passes through 4 on the vertical axis, so that's its vertical intercept. We see that g of x has a vertical intercept of 4, so it's probably blue is g of x. And then for the red line, we see that it intersects the vertical axis at 1, and we see a plus 1 in the f of x, so probably the red one then is f of x. Okay, and we're trying to find the point where they intersect, which looks to be this point here. And notice, first of all, from our picture, it's really hard to tell what the coordinates there are, right? Because they don't land on nice numbers. I mean, it looks like it's a little less than 1 and a little less than 4. So I don't know, like 0.9 and 3.7. I don't know. It's really hard to tell, right? So we want to find the exact coordinates there. So we're going to have to find some algebraic way to do it. By algebraic, I mean using some solving of equations or something. And how might we do that? Well, first of all, notice at this point where the two lines intersect, they have the same output value, right? And I know they also have the same input value, but in this case, I'm focused on the fact that the output values are the same, right? Which means that for inputting a certain value of x, we get that the value g of x, which represents an output, okay, that's going to be equal to, well, inputting that same value into the function f, which the output there would be represented by f of x. So we've got this equation where g of x equals f of x. But notice for both of those we have formulas up above, right? F of x, or excuse me, g of x is equal to that. F of x is equal to 3x plus 1. So what we can do is take each of these and substitute them into their appropriate sides here. So we would have negative 1/2 x plus 4 equal to 3x plus 1. Okay, so we can solve that to find the point of intersection. So I'm actually going to go to another slide. I have a little bit more space to work here. And I'm going to write our equation up here in the corner. So we have negative 1/2 x plus 4 equals 3x plus 1. And we need to solve for / isolate x here. So to do that, we first need to get all terms that have x's on one side of the equation, all terms that do not have x's on the other side, and we also, well, yeah, in this case, I'm going to move the negative 1/2 x to the right-hand side, since it's negative and the 3x over there is positive. Okay, so these will cancel. And we now have 4 equals, and we have to add the 3x and the 1/2 x. I'm going to do some scratch work over here. Notice I can write the 3x as 3 over 1x, okay, because 3 is the same as 3 over 1. Plus we're adding a 1/2 x. In order to add two fractions, we need to have a common denominator. Looks like in this case, between 1 and 2, our common denominator would be 2. Which on the top will give us 6 over 2x. On the bottom will give us 1 over 2x. When you add fractions, recall that you just add the numerators. So we're going to do 6 plus 1 here. So it becomes 7 over 2x. So in our equation, adding the 3x and the 1/2 x gives us 7 over 2x plus 1. We can now subtract 1 from both sides. So these cancel out. We're left with 7/2 x equals 3. And then move this up to here. So to isolate the x now, we need to divide by 7/2 on both sides. So if 3 equals 7/2 x, we will divide by 7/2 here, divide by 7/2 here. These will cancel. So left with x equals, and now we're back to some division with fractions. So we have 3 divided by 7/2. Recall we can make that 3 a 3/1. So then to divide with the fractions, we do 3/1 times 2/7. Multiply straight across, so 3 times 2 gives us 6, 1 times 7 gives us 7, so we have the value of x at that intersection point is 6/7. Whew. So much fun, right? Yeah, I figured you felt that way. Are we done? No, we are not, right? Because we're trying to find a point of intersection. And right now, all we have is an input value or an x value. So how are we going to find the related output value for the point? Right, when you take the 6/7 here and plug it into one of our original equations, turns out it does not matter which one we plug it into. And because of that, I'm going to plug it into the 3x plus 1 just to avoid encountering more fractions. Okay, so I'm going to erase some stuff here. So when we do that, so 3x plus 1, I believe was the f of x. So we're doing f of 6/7 equals 3 times 6/7 plus 1. Again, we got to do some multiplying with fractions. We'll make the 3 a 3/1. Multiply straight across, we'll get 18/7 plus 1. 18/7 plus the 1, we can make 1/1. Again, make the common denominator, which would be 7 here, so I have 7/7. Add the two fractions, which then gives us 25/7. Again, we just add the top. So that would be our output value. So therefore, we now have that our point of intersection should be 6/7 25/7. Okay? Now, I know I just did a lot of stuff, so it might be helpful to go back in the video and just follow it again, or make it go a little bit slower, or pause it so that you can catch up with everything. The last thing I want to do is just go back to the graph and see, does this answer make sense? 6/7 25/7, does that seem like that could be, whoops, where the intersection point here is? Well, 6/7 is a little less than 1, which looks like that's where our input value is. 25/7, 7 goes into 25 3 times with 4/7 left over, so it's a little over half, 3 1/2, which looks like that's about where the output value is too. So that's how we can know that we're probably correct. Okay, that's all for now. Thank you for watching.